Alright, this is the rest of Lesson 3.1, and we're going to look at solving our systems of equations with our other two methods. Number 1, solve one of the equations for one of it. Number 1, the substitution method. Step 1 says solve one of the equations for one of its variables, and then substitute the equation from step 1 into the other equation and solve for the other variable. Substitute the value from step 2. This doesn't make any sense, so let me just show you how to do it. Alright, what you do is you solve one of the equations for one of its variables. So what you look for is you look for a letter that is by itself. So let's just, before we do anything else, let's identify which letters are by themselves. If I'm looking right here, this x has a 2, this y has a 2, this y has a 4, but this x does not have a number with it. Over here, I've got a y that doesn't have anything with it. I've got an x that doesn't have anything with it. But then I have a y that's all by itself. So I'm actually going to do b first because it's a little bit easier because step 1 is already done. Step 1 is to solve one of the equations for one of its variables. So, what I have is y is actually x minus 3. Okay? So what I'm going to do is I'm going to take this x minus 3 and I'm going to plug it into the other equation where the y is. That's step 2. So I'm going to come down and I'm going to rewrite, let me do it with, I'm color code this thing, 4x plus, and then equals 32. And I'm going to pause for a second. 4x plus equals 32, but what I'm going to do is instead of writing y, I'm going to write x minus 3. So what have I done? I've plugged the x minus 3 in where the y is. So where the y was now is an x minus 3. And then I solve the equation. Are there any like terms to combine? Well, yeah, there's a 4x and that's understood to be a 1x. 4x and 1x is 5x. I bring down my minus 3. Equals 32, and then I finish it. Add 3, 5x equals 35, divide by 5, x equals 7. Okay. Now, my goal here is to have an x and a y. X is 7, now I need y. Well, the very last thing I do is I take my x equals 7, and I plug it back into the very first equation. From step 1. Yeah, sorry. I got confused for 1 second. So I've got y equals x minus 3 something. But what is x? Well, x is 7. So y is 7 minus 3 is 4. So it's 7, 4. And that's the substitution method. So now A is a little bit harder because the x is not solved for. Nothing is solved for. But what I'm going to do, step 1, is to solve one of the equations for one of its variables. And it's always easier if you just find the letter that's by itself. So how do I get rid of, if I'm solving for x, how do I get rid of minus 4y? Well, I add 4y. So I've got x equals negative 1 plus 4y. Now, what I'm going to do is I'm going to take my negative 1 plus 4y, which is my x, and I'm going to plug it into the other equation where the x is. So step 2 is I'm going to come and I'm going to write my first equation, 2x plus 2y equals 3. But x is going to be negative 1 plus 4y. This is the rest of the equation. See if you see what I did there. The 2, the plus 2y, and the 3. But instead of the x, I'm going to write negative 1 plus 4y. I'm substituting. That's why it's called the substitution method. So now I distribute. So it would be negative 2 plus 8y plus 2y equals 3. And then I combine like terms. Negative 2 plus 8 plus 2 is 10y. They're on the same side, so you don't subtract them. I see a lot of you doing this. This is wrong. Minus 2y, and calling it 6y. That's wrong. Don't do that. And if you couldn't hear what I just did, you need to put your headphones on. But then you wouldn't hear me. Put your headphones comes on. Okay. Some of us try to watch them like a deaf person. So, how do you get rid of negative 2? You add 2. So you got 10y equals 3 plus 2 is 5. Solve for y, divide by 10, both sides. So y equals 1/2. Now, last step is to take the y equals 1/2 and plug it back in where the y was. So we've got x equals negative 1 plus 4 times 1/2. So negative 1 plus 4 times 1/2. I should have done that. Hold on. Negative 1 plus 4 times 1/2 is 2. Negative 1 plus 2 is 1. So x is 1. So that's the point. 1, comma 1/2. Before I do the elimination method, I'm going to let you try checkpoint number 1, which I think is on the next page. Pause me for a second. Try number 1. Okay, unpause me. I think the easiest thing to solve for would be this x right here. So step 1, x minus y equals 3. I would add y. So x equals 3 plus y. So that is my x. Now I'm going to substitute it into the other equation. So step 2, I write my other equation. And I'm going to take the the 3 plus y, and I'm going to plug it in where the x is. So I've got negative 3 plus 4y equals 2. Now what am I going to put in that parentheses? The 3 plus y. Okay, so I'm going to distribute it through. So that would be negative 9 plus negative 3y plus 4y equals 2. I'm going to combine like terms. The negative 3 and the 4 go together, and I'm going to have negative 9 plus 1y, and then I solve it. Add 9. Oh, sorry, I'm tired. So y equals 11, and then last step, step 3, is to plug what I got in step 2 back into step 1. So x equals 3 plus y, but y is 11. X equals 3 plus 11, which would give me 14. So it's the point 14, comma 11, because x comes before y. Alright, so now let's go back and let's look at method number 2. The linear combination method, sometimes called the elimination method. I'm going to write that down. Elimination. Do these lines help at all? I guess so. Multiply one or both of the equations by a constant. A constant is just a number to obtain coefficients that differ only in sign for one of the variables. Add the revised equations from step 1. Combining like terms will cancel one of the variables. Solve for the remaining variables. Substitute the value attained in step 2 into either of the original equations and solve for the other variable. Okay, let's just work it out. This is the method, and you may, hopefully, you remember this from Algebra 1. What you want to do is you want to line them up and add straight down. You want to line them up, add straight down, and make something cancel more specifically. If you look at them right now, and I want to add straight down, 4 plus 2 is 6, 3 plus negative 3 is 0, 1 plus 1 is 2. Your goal is to make something cancel out. Did it? Yes, it did. In this particular problem, the 3 y's cancel straight out, and you just add straight down. 4 plus 2 is 6x, 1 plus 1 is 2, and you solve it. Divide by 6. X equals 1/3. And now you take that x and you fill it back into either one of the first equations where the x is. It does not matter which one. Let's do the first one. I'm just going to take it and plug it in right there. So I'm going to write down 4x plus 3y equals 1. Come on, pen. And I'm going to plug in the 1/3 where the x is. Now 4 times 1/3, if you don't know what that is, you can type it in your calculator, but I'm going to do it by hand. You do 4 times 1 on the top and get 4. 3 times 1 is 3. and then you solve it. How do you get rid of add 3y? Add 4/3. You would subtract 4/3. So 3y equals 1 take away 4/3. If you can type it in your calculator, or I could get a common denominator, 3/3 minus 4/3. That's negative 1/3. And then how do you get rid of times 3? You divide by 3. So negative 1/3. Let's put parentheses around it. Parentheses, negative 1/3 divided by 3. Math, enter, enter. And I get negative 1/9. So y is negative 1/9. So it's 1/3, comma, negative 1/9. And I'm going to pause just a second and clean my screen. It just gets dirty and then it doesn't connect good. Hold on. Alright, I am back. Okay, let's look at B. I'm going to just erase all that. B. If I add straight down, 3 plus 5 is 8. 7 plus 14 is something, it ain't 0. 12 plus 20, not 0. So I need to do more. So what I do is I need to multiply one of these by something to make either x or y cancel out. And what you look for, does 3 go into 5? No. Does 7 go into 14? Yes, it does. How many times? 2. So you're going to multiply that whole thing by 2. Now if we multiply it by 2, it's going to give us 14. And if we add it, it is not going to cancel. So what we're going to use is a negative 2. So I'm just going to distribute it out. Negative 2 times 3 is negative 6. Negative 2 times 7 is negative 14. Negative 2 times 12 is negative 24. And then I bring these over. And I add. Now when I add straight down this time, negative 6 plus 5 is negative 1. The 14s cancel. That was my goal. I was trying to make them cancel. Negative 24 plus 20 is negative 4. I divide by negative 1. X equals 4. And then I take my x equals 4 and I plug it into either one of the first two equations where the x is. I'm going to do the first one. The only reason I picked the first one is because it had smaller numbers. That is the only reason. So 3 times x, but x is 4, plus 7y equals 12. And then I solve it. 12 plus 7y equals 12, minus 12. 7y equals 0. Y equals 0. So it's the point, remember it's xy, so it's 4, 0. Alright, now I want you to try this one. And if you're stuck, just watch me, that's fine, but if you want to try it, pause it. What I'm looking at is just 2 does not go into 5, but 3 goes into 6. So what I'm going to do, I don't know why I did that, is multiply the bottom equation by a number that would make the 6 cancel out. Well, 3 goes into 6 twice, so I'm going to multiply by 2. But that would give me a positive 6. I want the signs to be opposite, so I'm going to do a negative 2. So I'm just going to rewrite this one. 5x plus 6y equals negative 2. And then I'm going to distribute. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. Negative 2 times 1 is negative 2. And then I'm going to add straight down. 5 and negative 4 is 1. These are gone. Negative 2 plus negative 2 is negative 4. Divide by 1. X is negative 4. And now I'm going to plug that into either one of the first two equations. I'm going to do the second one this time for no other reason than the numbers are smaller. Draw a line. So it's 2 times x, but x is negative 4, plus 3y equals 1. So negative 8 plus 3y equals 1. Add 8. 3y equals 9. Y is 3. So it's the point negative 4, 3. Okay. Now it says solve by linear combinations. Now this one's different. Why is it different? Because 2 doesn't go into 3 and 2 doesn't go into 5. These are not multiples of each other. So when this happens, what you can do is up until now, I got tongue-tied, up till now we have multiplied one equation. Now we can multiply both. Okay, if you have to, you can multiply both. So the easiest thing to do is look at your opposite signs. Now this time both of them are. So I'm going to get rid of my x's. I can multiply the first one by 3 and the bottom one by 2. And if I do that, watch what happens. 3 times 2 is 6, 15, and 18. And then on the bottom, negative 6x, let's see, negative 4y, and positive 4. Because I multiplied the top by 3 and the bottom by 2, now look what happens to the x's. They cancel. And then I add straight down. 15 plus negative 4 is 11. 18 plus 4 is 22. Divide by 11. Y is 2. And now I can take my 2 and plug it back into either one of my first equations where the y is. Let's do this one. I want to do it in black. 2x plus 5 times y, but y is 2, equals 6. So 2x plus 10 is 6, minus 10, and I'm hoping you remember doing this in Algebra 1, because I'm doing about 3 weeks worth of stuff in one lesson. So x is negative 2, comma 2. And, oh gosh, is this, oh, good heavens, how long is this video? Ooh, okay, I'll hurry. Alright, so you can try these, and you can solve them either way you want. I like the add and down method. I'm thinking 2 goes into 4 2 times, 1 goes into 2 2 times. So I'm going to multiply this thing by a negative 2 on the bottom. So the top one stays the same. Something nice happens in these. Negative 4x, positive 2y, and negative 6 if you distribute it. And look what happens. The x's cancel, and the y's cancel. So negative 4 plus 4 is 0. 2 plus negative 2 is 0. Equals 5 plus negative 6 is negative 1. Is that true? No. So it's no solution. That means that these lines never cross. They're parallel. Oh crap. 3 doesn't go into 4, 6 doesn't go into 8. So let's multiply the top by 4 and the bottom by 3. So on the top, I would get negative 12, positive 24, and 4 times 9, 36. And on the bottom, I would get 12, negative 24, and negative 36. Look at that. Everything cancels. So if everything cancels, you get 0 equals 0. That is true. So that's many solutions. It's one line, like we talked about yesterday. Last thing is you could try these two. Oh, I'm so sorry. Oh, I'm tired. Let's see. So you look at what you could multiply by. 2 goes into 6, 3. So let's multiply the top by 3. And I'm just going to rewrite it underneath. 3 times 2 is 6. 3 times 7 is 21. 3 times negative 4 is negative 12. And now I'm adding these two equations. Those cancel, those cancel, those cancel. So it's 0 equals 0. So this one is many. And then here, this is ugly. This 3 won't go into 7, 5 won't go into 11, so I just multiply by opposites. I can multiply the top by negative 7 and the bottom by positive 3. So if I multiply the top, it'd be negative 21, 35, and negative 70. And then on the bottom I get positive 21, negative 33, and 60. Those cancel. 2 and negative 10? Yeah. Divide by 2. Y is negative 5. And then I plug it into either one of my first equations. Let's do the first one because it has smaller numbers. I'm sorry. This is the first day back from the snow, and it's hitting me that I've slept late every day but today. 3x negative 5, plus 25 minus 25. 3x equals negative 15. Divided by 3, x is negative 5. Yay! Negative 5, negative 5. And that is all.